there, this is video PR3 on experimental probability. Okay, so I guess I don't know that I ever wrote it on here, but the idea is to calculate experimental probability, you have to do an experiment. And the experiment we're going to do is we're going to toss a dice. But I thought trying to be more online and later on this in the assignment, it makes it so much easier, is we are going to use this website. Okay, so I'm going to stop my share and see if I figure out how to get back there. Okay, so I typed in Academy Mio dice roll and it came up, but you have the full, excuse me, URL there. So this is the statistics of rolling dice, and it's a nice little website here. Okay, so we want to make sure that this is set to 1, and because you can change it, you can have 2, you can have a whole bunch of dice. But I only want, I'm gonna do 6, but I only want 1. Okay, and I'm gonna click it. So it's, and you can see I rolled a 2. Now we have frequency here with a frequency of 1, which pretty much just means that's all I rolled. I rolled a 2. You can see. There we go. So it says hit the roll button 12 times. So look, there's the 6. Okay, and notice it says 2 here, right here. So I'm just going to not really pay attention, and I'm just going to keep going there until it reads 12. Now, if you screw up and you go too many, so it says roll 15, if you need to start over, just click there. I couldn't find anywhere else to restart it, so that seems to work. There, I got 12 again. Okay, so now what I want you to do is on your sheet, I'm going to have to share different again. I'm going to be flipping back and forth a lot here. Okay, so what we're going to do is you are going to do it on your own, because I am going to check to make sure you do not have the same answers as I do. We're going to have our frequency here, and then we'll figure out probability. I'm going to go back. Nope. There we go. All right, so now we're going to read our table. So 1, if I read sideways, that had a frequency of 2. I say one more time. Don't copy these answers. You need to do it on your own. And if we look at number 2, that also showed up twice. And a frequency 3 showed up once. 4, 3 across showed up 4 times. 5 showed up once. Whoopsies. Put 1 there. And 6 showed up twice. All right, I'm just going to clear that. Oh, that looks like that's all I have to do. Okay, so just I figured that out just now. Okay, never mind. There we go. So now all right, so I copied my stuff down. Now probability. Oh, I should check. I want to know my total times I rolled. Now, according to the other screen, it was 12 times, but I want to double check. So 2, it's 4, 5, 9, 10, 11, 12. That's what I was supposed to do. All right, so probability. So I got a 1 twice. out of 12. My sample space on all of these is going to be out of 12. You could do the math with each one. I just find it easier to figure it out. What do I want to say? To write it out first and then figure it out. I don't know if that made my calculator any better. 2 divided by 2. Whoops. Try it. Technical difficulties. Okay, it was better with the lights off. So now we're going to go 2 divided by 12. Look over there. Oh, look up there. That works. That works. Just awkward to write. Okay, so I'm going to round to 2 decimal places. So that's going to be 0.17. And so is this one. And somewhere else. All right. Now if I go 1 divided by 12, 0.08. 4 divided by 12, 3.3 repeating, 0.33. Oopsies. And that one is going to be the same as that one. Now, I want to do the total benefit too. What should it add up to? Think about it. If I roll the dice, I'm going to get one of, I am certain to get somewhere between 1 and 6. So if I add these up, they should add up to 1. Let's see. Yeah. There you go. It worked out to 1. I was all ready to give you this nice little lecture about, well, you know, because we rounded here and we rounded there. We pretty much rounded on every single one of those. I was prepared to get like 0.99 or 1.0, but it looks like the times that we rounded up and the times that we rounded down just managed to cancel each other out. All right, so let's look at the last couple of questions. Now, again, these will be specific to yours, to your own. And I'm going to make sure when I check your stuff that it is not the same as mine and not the same as this one either. Okay, did one number appear more than others? Yes, for me, the 4 did. Was there in one number that didn't show up at all? Nope. But let's see, 3 and 5 only appeared. Let's see, once each. Because my brain is thinking, you know what, if you have a dot and you roll it 12 times, wouldn't you think that you should get two of each? 6 choices, 12 things. But that's randomness. Not exactly. Okay, so that's the end of that. Now the lab continues on the next page. All right, so what we're going to do is it says combine your frequencies with those of 3 other students or repeat the experiment. Okay, so I'm just going to copy my answers from here. There we go. And I am going to, I'm going to show you the first one, and then I'm just going to pause it while I do it. All right, so I'm back here. I'm back to my website, and I'm just going to quickly roll 12 times. Now look at last time I got 4th most, and this time I didn't get 4 at all. So now if I want to read my table, 1, so here's my 1, I go across, and that says it showed up 5 times. And I'm writing this on my chart. And there's my 2, and it showed up twice. And there's a 3, and it showed up once. 4 didn't show up at all. 5 showed up, looks like 3 times. And my 6 showed up once. So if I add this up, 5, 6, 7, 8, 9, 10, 11, 12. I just want to make sure I got right. Although, truth be told, there's a 12 there. All right. So what I want you to do is pause the video. And I want you to, all right, so you got 2 choices. If we are doing this in class, or maybe even online, you can do it. I want you to share your data with everybody. Maybe just ask you to do that. Or I don't know, but I'm going to pause and I'm just going to generate the data myself for this video. Okay, so I have gone through and I have done this 3 different times plus my original. Show you where we at. Nope, this one. So either using other students' data or like me, I just kind of, what's the word I wanted? Gone. Oh, I just generated my own data. I've got this table filled in. So now what I'm going to do is I'm going to total it going across, and then we'll do the probabilities. So 2 and 5 is 7, 8 to 9. All I'm doing is totaling 2, 4, 6, 7, 1, 2, that's 8, 9, 10, 11, 3, 4, 5, 7, 8, and 2, 3, 4, 5. That's kind of weird because I was looking at that and I was going to say, hey, look how all the numbers are almost the same. And then, 6 wasn't ruled very much. 4 was ruled quite a bit. That's nature, randomness. Okay, but that's okay. So now our probability is going to be 9. 9 times we got a 1, and each of these is at a 12. So 12, 24, 36, 48. Okay, so all I was doing is I combined them. So essentially it would be the same as rolling a dice 48 times. But we just did it as a series. So again, if we combine class data, it would probably be faster. All right, let's do the math. 9 divided by 40. Oops, calculator on. 0.875. So I want 2 decimal places, so that 7 is going to make 8 go up. .145. So the 5 is going to make that 4 up. So it's going to 0.17. Now I saw that somewhere else. There we go. 0.23. So if we compare okay, so this was our number when we just did a total of 12. And our lowest was 0.8 and our highest was 0.33. Okay, so that's quite a big difference. If you look here, my numbers are getting closer. So okay, I do this. 0.33 minus 0.08. Right, so that gave us a range of 0.25. Remember range from last semester? Whereas this one, 0.23 minus, okay, that's going to be 0.1. So these numbers are closer together than these ones. So when I did 48 trials, they're closer together than when I did only 12. Now what I guess that's what I want to write here. The combined probabilities are closer together than the original. .13 versus 0.25. Oopsies. Poor range. Okay. All right, so we're going to go back to our website and we're going to check the roll automatically box and let the program run until the number of rolls is around 1,000. Okay, it won't take that long. But if you're somewhere between like 950 and 1050, it's close enough. So pay a little bit of attention. And then we'll answer those questions. So, okay, so I'm going to clear this off, which I just learned. Just click on the little box and click here, roll automatically, and away it goes. And you can see here, the numbers are going, and that's way faster than you could do it yourself. And we're at 100, and you can actually, let's click there, what happens? Oh, good, it keeps going. So when you want to stop, all you've got to do is click on that stop. You can see the lines are changing length. So what do you think is going to happen? While this is running, I probably should ask you to make a prediction. So we're at 300. What are you seeing right now? I'm going to pause this. All right, you can tell I paused that for a second, and because you know what, it wasn't that exciting to sit there and stare at the screen as it went up. I messed up it at 1,005. So what do you notice about the frequency of each dice roll result? I notice, compared to what we were doing before, that the lines are fairly close. I also notice my frequency has changed, right? So now my number here is like 160. So this might be 160. This might be 170. I don't know exactly how long these lines are, but the lines are kind of similar in length. Okay, so if you remember what that looks like, oh, you know what? Hold on. You guys familiar with the snippy tool? I love my snippy tool. Let's see if we get that. Okay, just hide that for a sec. I'm gonna do this, and we're just gonna go there. All right, so that's 12 now. If I bring this back, there, look at that. Snippy tool to your friend. So if we look at 12 dice rolls, you can see your lines are kind of, well, these ones lined up, but they're often all over the place now. I just want to do it again. There. Ooh, that one's even better. Right? Because this is like randomness. In this one specifically, I didn't get any 4s. But when you do it 1,000 times, the chances, the probability, the chances of you not getting at least 1 4 in there, it's way down. So these lines are becoming closer and closer to being the same length. All right, so that would be what I noticed about the frequency. The lines, the frequencies are very similar. I mean, truth be told, because our frequency is 0 to 5 here, and this is like 0 to 360, there might be a difference in them, and I'm sure there is, but it's not as big, or it's not as much in comparison. Okay. Let's get back to the worksheet. Okay. So how does the 1,000 row graph compare to original 12 row graph? Oh, I guess I'm kind of repeating myself here. The frequencies. Seem more similar. In the 12. All right, so what conjecture can you make about a 3,000 row graph? Make one. I think that it seems like the more, what's the word I want? The more times we roll the dice, the more experiments we do, the closer the numbers are getting together. That's my hypothesis. The frequencies. In other words, lines on the same length. All right. So back to, whoops, one. Third time's the charm. Okay, something went weird. Oh, let's try that again. Of course, I'm recording when it gets all weird. I'm gonna go here and share. And I don't know what my, okay, so I am just going to pause the video because I don't know what's going on. And I'm going to go back to that website and I am going to test my conjecture by letting it run for 3,000 times. It'll take a couple of minutes. And by then I'll figure out. Right. I seem to, I don't know, I figured out how to get it to work. And the number of rolls was 3,006. So I did not too bad. And my conjecture was that the lines would become more similar in height. And you know what? When I compare it, and I can bring it back up, tool, to the 1,000 dice, I don't think it's any better. So, oh well, my conjecture wasn't quite right. I do think, though, if we up this to 10,000 rolls, that maybe they would get closer together. Because I'll fess up. What was supposed to happen is the more times you roll the dice, the closer the experimental probability will get to the theoretical probability. And the theoretical probability is the one that does not include randomness. So let's just get that on worksheet. What were the results? Well, you know what? I'm going to write unexpected. The lines were not closer in length. Randomness. You never know what's going to happen with it. Okay, so what conjecture can you make relating the number of rolls and the frequency of the dice roll results? Well, I'm not going to make a conjecture. I'm going to tell you what happens. The more times you complete an experiment, the closer the experimental probability to that. All right, that was, I'm hoping when you did it, maybe it worked a little bit better than it did. All right, but here, dun, 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 look, 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 look. There's a very cool assignment for you. And most of it isn't really mathy. And it is based on watching, I think it's a 5-minute video. It's part of a movie called Rosencrantz and Guildenstern Are Dead. Now, I'm thinking at this time of the year, when you're watching it, you should have already done Hamlet. So this is those two guys. So it's a really cool play. It's, I think it's a really funny movie that's worth watching the whole thing, but it's just one little section of it, and it does talk about probability. So you should watch it and do the assignment and hand it in. Thanks. Have a lovely day.